In this demo, we'll add a potentiometer and use it to control the step speed of the 12-volt ungeared stepper motor. Apart from the potentiometer, everything else in this circuit remains the same. So what we'll do now is we'll connect a potentiometer to the Arduino. We're going to take analog measurements of the potentiometer's resistance and use that to control the speed of rotation of the motor. So I have, I'm going to plug the red wire to the 5 volts. I'm going to put the black one to ground. I'm going to use digital pin 0, analog pin 0 to take measurements. So in the sketch we have pretty much what we saw in demo 1 sketch. We use the stepper library just like before. We set the number of steps per revolution. We initialize the object exactly the same way as before. Don't do anything in the setup. And then in the loop we grab a reading from the analog pin 0. Then, because every motor is different, as you remember in the first demo, by doing trial and error, I determined that the top speed of my motor is 300. So what I'm doing with the map function is to translate the value that I'm getting from the potentiometer reading, which is from 0 to 1023, to a value between 0 and 300 to match the capabilities of my motor. Then for as long as the speed that the potentiometer provides, or the reading the potentiometer provides, is greater than 0, then I'm taking that mapped speed and passing it to the motor via the set speed function. And every time I do that, I just instruct the motor to go ahead by a single step. Now you are able to, of course, play around with the values in here, so you might choose to go, say, 2 or 3 steps ahead every time that you want to move the motor. I'll show you what happens when you do that. So let's upload the sketch. Okay, and let's move the potentiometer. Oops, of course I've made a mistake with my connections because I couldn't see very clearly. So that's got to go there. There you go, that's better. I didn't connect power properly. Alright. So 0, and then it's maximum speed. It's also quite responsive. Now what happens if I change the step number, let's say, to 5? Will my motor move 5 times as fast? Let's see. Doesn't look like it. Okay, it's not obviously missing any steps. I think it is moving a little bit faster than earlier. So taking, in this case, 5 steps at a time seems to be able to move the motor faster. What if I make that 10? Let's see what's the limit and when it's going to start skipping steps. Okay. I'm at maximum now on the potentiometer. It doesn't look like the motor. Okay. There was a lag. So the motor. Okay. Doesn't seem like the motor is capable of following quickly enough the position of the potentiometer. So now it's maximum. The motor is still not moving really at maximum speed. At some point probably sinks and it starts moving fast. So yeah, 10 is probably not going to do it if you want to have some good correspondence of the position of the potentiometer with the motor. Let's go back to 1. So, yep, 1 works. So feel free to play around with these values and see at which value you get the speed versus reliability characteristics for your project.